Hi everyone, welcome to day 8 of Spark Learning. So I haven't done video for last few days and I was in a thought process how we can talk about architecture, right? When you watch the Spark architecture videos, you might definitely be seeing and hearing so many terms. I want you all to know all the terms, but at the same time I don't want to make the things complicated, right? Today I'm trying to explain the Spark architecture or how the Spark processing done, right, in most simplest way, and I will also try to cover very high level, like what are the terms which you should know, and ongoing, like we will be talking more about the other terms, right? So talking about Spark, right, the major thing which you need to know: a driver program, cluster manager, and worker node, executor, and task, as you're seeing in the image, right? So what is these things, right? How Spark is accomplishing that 10x or 20x of faster processing as compared to our traditional data processing system? How RDD is helping? So that is what we are going to talk today. So the main reason for faster processing, right, is parallel processing. So Spark is dividing your data into multiple partitions, which you will be seeing how it is in the next slide, and it give that processing activity to each executor or node to process that particular partition, which help you to accomplish the data faster because you have multiple executor that help you to process. Like you have a major requirement to get the data, but you like then what do you do? Let me tell you the flow. Like you get a request that comes to driver program. So driver program send this to the cluster manager. Cluster manager decide, okay, I have two nodes as per this picture. I have two nodes, so I'll give this split it into like two parts, and I'll give one part into the worker node 1 and the second one to the worker node 2, right? Then this goes to the partition and read the data and do the processing and send that back to the driver program, correct? So what happens here is maybe if you are doing this as one go, you might take 10 seconds, but this is divided and being done by two machines, so you might take 5 seconds together plus an additional of 1 second. I maybe instead of 10 seconds you can accomplish this in 6 seconds. So keep one point in your mind. Unlike whatever we learned, or I know, like when we were talking about RDD or data frames in a previous slide, previous videos, you may have never thought about the parallel processing. Now hereafter, anything and everything which we are thinking about RDD or Spark, right, I want you to think this way. So it comes to driver program, it goes to cluster manager, it's sent to node, right? And there will be multiple tasks, multiple executor in a worker node. So what is a worker node? You can keep like you have a machine that is having RAM and CPU. You have a machine. So worker nodes can be considered as multiple physical machines. But whereas like executor is like consuming a chunk of like CPU and memory and building that resource groups, right? So keep this in mind, so that now let us take a real time example, right? You have a requirement to process your data faster, right? When previously when normal cases we will say, okay, let us increase the RAM, let us increase this CPU, right? Here what we'll say, okay, we'll add an additional worker node, right? Or maybe if you have worker node and resources available, let us see is my data partition, because if you have two worker node and if your data is not partitioned, it is not going to be in parallel, right? Because both of the workers are going to access the same data, right? So this is necessary that partition is also taking a part when this physical machines are trying to deliver the data faster, right? So keep this architecture in mind. I'll quickly read through what I have listed, few points which help you to like strengthen that statements what we discussed. Then we'll move on to the next slide. So one is driver program, as we said, like the first part of it, right? You see the Spark context. So that manages the execution, and cluster manager allocate the resources, like who has to do what, and executor perform the computation and the store the data, right? Like you are processing it into taking that into memory, and all these things are being done by this executor. And tasks are like work assigned by a driver. Then you will have multiple tasks, right? Some executor might be powerful and it can complete the first task in 10 seconds, and you still have another 10 seconds, you can take the text. So that way, this like, yeah, keep the very high level of parallel processing in mind, so that like you can go deep into that and understand each term and relate the statements and points coming on your way. There are so many statements I can share with you, like lazy evaluation or jobs, nodes, right? The worker node is nothing but nodes. So there are so many terms, but I'm not planning to cover all that one by one, but I'll be adding all those terms and definition in the description of this video, so that like based on this base which I am setting here for you, right, which will help you to relate to that terms. Okay, how this term is going to work, and how when something fails, right? That's what we're going to we talk about in the next slide. When it fail, what do we do? All these things, right? So we'll move on to the steps. So driver submit a Spark job, and a cluster manager allocate the resource. Same thing, I think that what you are seeing on the top is resemblance, but here it is a step by step. Executor that runs in the parallel, and the result is coming back to the driver program. Okay, so hope this particular part of the video is helped you to get a very high level idea about how the process flow is. So when you think about when you are like doing an action and using Spark APIs, this is what happening behind the scene, right? So like RDD and parallel processing. So we have talked about in the previous slide, we have never talked about anything related to data here, right? So all we talked about was like, okay, we are getting a task to be done, that's going to cluster manager, and cluster manager dividing the task and giving to the different worker node, right? And all the tasks which we do is related to data, right? So how this is working, correct? So the first point, right, RDD is divided into partitions. You know, like RDD is, what is RDD, right? So RDD divide your data into multiple partitions. You can see I have a data set from item 1 to 25. This is divided into 5 sets here, correct? So now you like below the image, it has mentioned worker, Spark executor is the same thing we have discussed here, worker and executor, right? So the same worker is communicating to your parallel system and getting you the result. Now the benefit here, right? I have like 3 workers that is accessing your 5 data, and I said like my worker 1 can like take care of 1 and 2, or like 1 and 3, and my worker 2 can take care of like 2 and 5, and my worker 3 would take care of like partition 4, right? So that way we are able to like accomplish this result in parallel. But there are issues, right? You might be like one worker node may fail. So how that those kind of, right, all this coming into picture when we talk about like how this ensure. You may have heard about the word fault tolerance, right? You may have heard about this is resilient, all these things, right? How that is accomplishing, I'll quickly tell you those points in high level, because now you understood how the request is coming, how that is like reaching into worker, and worker is communicating to data. So unlike like HDFs or big data, right, the data is stored here in terms of Spark, or it is using S3 bucket or data lake to store data lake to store the data. Okay, Yeah, so yeah, we understood that RDD split the data into different partitions, and we have a command that help you to understand like what is the partition it split, and you also have flexibility to divide that into number of partitions you have. We have those commands, so or like APIs. So before I dive into that, I want you to understand what is happening behind, so that like you can keep your thought process according to this backend, which help you to confidently apply this transformations, and as well as like convey why you are doing this, right? Now partitions, right? So which the second point, partitions are processed in parallel, which as the image says, like partition 1 3 are processed by worker 1, right? Like you can see this, at a time 1 2 and 4 are being processed at a time, and then the second one will be taking, correct? So this parallel processing is what enabling PySpark to deliver the results faster, correct? Otherwise, like if it is not parallel, if it is a linear, then it is not going to it has to wait like all the like 3 operation has to go in serial, right? So here a worker node will have its CPU, its memory and everything, and Spark, like Spark does everything in memory, right? It's an in-memory one. So it tries to do everything in worker node, and so that like you don't need to move the data from one node to another, or those kind of transfer effort is not required, which help us to improve the performance. So this action can be called as shuffle. But in some cases, right, some operations like you are going to group something, there are based on how your partitions are. If your partition is not optimized, those cases shuffling is necessary, but always the first priority for Spark is to have this locally processed and reduce the transfer between the networks and moving the data between, right? So well, like you might think, okay, it's a very very small record. Think about millions of data and TBs of data being processed. So I want you to think that big number mode, so that like how important it is to process it locally rather than moving between the workers. So now I will like conclude this video just by adding one key point: fault tolerance. What is fault tolerance? Suppose like now we are not dependent upon one machine, right? We are depending here upon multiple worker node, or what multiple machines. What if like one machine goes, right? You are responsible. You cannot, okay, my like machine like worker 3 is not working, so I don't process your partition 4. You cannot tell that, right? So you should have a mechanism, you should have a mechanism that help you to make sure that even if my worker 1 goes, I have a plan B, right? So here think like your worker 3 has gone. So now what happens? Your partition 4 is not processed yet. So there is a mechanism called lineage, where like however it is running in parallel, Spark keeps a track of, okay, what has completed and what is on the point, and if like node health, right, if the node is working, all these things, right? So by having by having this checking, right, they identify, okay, my worker 4 is gone. So what I need to do, I need to like I assigned a task for worker node, like worker 3, let us call it like worker 3, which is processing partition 4 has gone, right, in this example, which the image is on the right side of the slide. So here we learned that, okay, my worker 3 is not working, what should I do? Think, right, if you gave a task to 3 of your team member, and the third team member is on leave, but you still have to make sure that however that person is leave, do you have a backup? If you have only this 3 team member in the team, all you can do is like give that task to any of this member or split among them, right? So if I had this scenario of like worker 1 goes, there are 2 partitions, so I'll be giving that into these 2 people. based on the configuration. All these things comes into matter, but keep this in mind. If one of this team member is on leave, if you give that work to the other team member to accomplish the goal, if one of the worker is failed or it is not working, you are going to assign that partition processing work to any of the existing node. So there is something called, we'll be talking about DAG and all these terms, but there is a lineage which Spark always keep a track of, like what is happening, what is missing, right? So that like it reassign the task and make sure that your like processing is done by any of the other backup or this existing worker to accomplish your result. So in case of Hadoop, right, what they have done, they usually store this data in workers. So what if the worker goes, right? When your worker fail, you'll also losing the data in that case, right? So there, Hadoop was taking an approach of like storing the data, and this like the item 1 would be stored in 2 places, or like item 6 would be stored in 2 places, so that like even worker 1 goes, worker 2 has the same information, maybe worker 3 will have some piece of the information, they would be able to process it. That is how like Hadoop was doing this. But in case of Spark, Spark is not storing the data locally in nodes, it is relying on S3, like S3 in case of AWS, and data lake and all these storage mechanism to store the data, so that like workers are not directly responsible to manage your data, they are responsible to process your data. So that is how like our like Spark here is trying to like in when it comes to Databricks, so like this is how it is going to avoid that needing of keeping multiple copy of the data. So here in this video, while concluding, all I wanted to tell you is like understand that this is how the requests work, and Spark is accomplishing the performance in a faster manner by running this in parallel. So when you have to increase the performance, you need to see like, okay, is my worker nodes are used, optimizedly used, is my partition of the data, right, partition of the data is right and optimized. This kind of thing is what you have to really think about when you are going to do an optimization, when you are going to do a processing, right? I want you to like think these lines, so that like you will be able to make use of the Spark architecture in a very like most efficient manner. I know like we haven't talked about so many parts and more internal of these things, because my goal was to keep it simple rather than going in deep. Having this very high level idea is going to help you to understand when we talk about parallelism, when we are going to talk about other terms which is related to the cluster related nodes, right? These informations are more than enough, and wherever like if I feel that okay, you need to understand more detail, I'll spend some time on the theory in the same practical thing, because to be open and honest, right, I'm not a theory person, and maybe some of you are watching this video might be watching all because you wanted to understand that, but other than that everyone wanted to see okay how this work and how this is going to run, right? Now this base is really going to help you when we are going to do the practical hands-on sessions in the upcoming days. Yeah, thank you for watching, and hope this help you to get that base idea about this. Comment if you have any questions, and or like and subscribe. We'll see you in the next day. Thank you.